Mid-1994, Verwater and Van Seumeren started with the preparations of a big challenge. Shell Malaysia asked us if we could recommend a fast, economical and safe way of making room for a new extension to their plant. Their problem was an oil storage tank, which was standing on the proposed site. Our solution? To jack and relocate tank 1109, 23 meters high and 70 meters in diameter, to its new location. Once the tank had been thoroughly cleaned, work began on preparing the transport road and the preparations for installing supporting structures inside, to ensure the double-deck floating roof stayed in position and could not distort. The plan would be to first jack up the tank, weighing over 1500 ton, to a height of 60 centimeters using beams. When the welding is completed, each joint is magnetically tested. The roadway is being laid by local workers and progress is very swift. An octagonal steel supporting structure was assembled and 16 load-bearing brackets welded to the outer shell. Between these brackets and the central supporting structure, a frame had been installed. In addition, to minimize the sag of the tank bottom, this central frame was welded to the bottom of the tank. The total structure weighs 55 ton. Once all the welded joints had been tested, work could begin on fitting the jack stops. The jacking beams are positioned by crane. A total of 80 jacking stoppings were required to jack up the tank. Additional wood blocking is then stacked in order to distribute the weight of the tank evenly. Then the actual jacks can be positioned. The last job is to connect the hoses to the central hydraulic system. When the pump is started, water can be forced into the jacks at a pressure of 400 bar by opening a valve. The jacks are slowly raised under the carefully controlled water pressure. Once the full stroke of the jack is reached, wood blocks are placed under the sides of the jacks. When the pressure is reduced, the jack pistons retract on their springs.
For jacking inside the tank.
Because of the size of the tank, jack stoppings also need to be placed inside the tank to ensure that the whole structure will be raised evenly. A safety valve ensures that the water is released from each jack as it reaches its maximum pressure. When the tank has been raised to a height of 60 centimeters, the jack stoppings are placed underneath the tank shell and the tank resumes its slow journey upwards. The final working height of 240 centimeters is achieved, and work can begin to lay the transport roadway under the tank itself. The self-propelled modular trailers, or SPMTs, arrive and are unloaded, checked and assembled for the task in hand. SPMTs with a total of 88 axles and 352 tires will be used to relocate the tank. Trailers are positioned under the outer shell and 4 in the center of the tank, underneath the central supporting structure. The SPMTs are positioned precisely so that each is lying at a slightly different angle to the others and to the direction of travel. Once the STMPs are in position, the tank is slowly lowered on them. When the jacks are released under the tank, it is then supported on the 16 SPMTs and the stoppings can be removed. The roadway is extended so that little or no subsidence can occur. All the SPMTs are interconnected centrally, and the wheels can be set to the correct angle by means of this computerized drive system. The big day, Wednesday, April 2nd, 1997. The day begins with a special blessing ceremony from local priests from the Muslim community. Centimeter by centimeter, inch by inch. The Colossus leaves the spot where it has stood for 16 years. Shell had considered other options, such as demolishing the tank completely and building a complete new one, or dismantling the tank and rebuilding it piece by piece. But in terms of speed and efficiency, neither option came close to this solution. The SPMTs are divided into 4 separate hydraulic groups, the oil pressure being the same in each group. If there is any unevenness in the transport road, each axle of the SPMTs can be individually adjusted so that the tank will always be kept absolutely level. One of the extra difficulties presented by this particular operation was a difference in height from the old location to the new position. This difference of 3 meters over 650 meters meant that each SPMT was set at a different height. Throughout the operation, the floating roof was monitored for any signs of distortion, and the verticality and out of roundness was constantly measured, and at each time were found to be well within the preset margins. Each SPMT is driven by a hydraulic power pack and has a carrying capacity of 34 ton per axle, with 88 axles giving a total available capacity of nearly 3,000 ton. The transport road had to be capable of withstanding the pressure of tank, structure and SPMTs. What was considered to be impossible had been perfectly accomplished by the engineers of Verwater and von Seumeren. And because of this ingenious jacking and transport operation, this tank will provide many more years of service to its owners. Once on its new position, the tank will be transferred from the SPMTs to the jacks, and the jacking procedures repeated and the tank lowered onto its new foundation. Verwater and von Seumeren's great challenge has been met. And it certainly won't be the last for this Dutch partnership, because everything is possible in the world of tank relocation.